Hello, everyone. This is Nishtha Chouhan. I'm a senior product marketing manager at Denodo. Today, I'm going to cover the topic advanced data analytics and machine learning using logical data fabric. I want to thank organizers of DataCon LA and for giving this opportunity. To give you a sense of what's a high-level agenda for today's top session, I would like to start with understanding why businesses need to be prepared for advanced analytics, and what are some of those use cases and the data challenges that these businesses face. I would like to introduce you to Data Fabric for advanced analytics. Some of you must be already familiar with this topic. And then why go a logical data fabric way? To wrap this up with some of the customer success story and how they use logical data fabric for their analytical needs. So let's look at why businesses need to be prepared for advanced analytics. When we look at traditional analytics, it allows us to understand where the problems are. But really, advanced analytics goes beyond traditional analytics to discover the deeper insights and make predictions or generate recommendations. So let's look at some examples. If you look at marketing and the marketing function, you really, from the traditional analytics perspective, you're tracking digital campaigns and you're trying to understand email and social media feeds. It's really like trapping what's happening now. But advanced analytics help marketers understand where could be the increased customer engagement, which campaigns could work better than the other. It allows marketers to A/B test their campaigns and predict based on the results on the testing which particular campaign would perform much better. And it allows you to add different variables. It could be location, demography, and really segment that and target the right segment. And now if you look at operations, advanced analytics allows from the operation perspective to be more proactive than reactive. So if you were just to look at traditional analytics, it will help organizations understand historical data, and based on that, like it provide information on the equipment parts or spent, how much was spent on which parts, and what were the failures by customers that were reported, and that could help them meet the customer partner data request and all that. So it helps understand what happened and where the problems are. Now, advanced analytics helps them develop new services that help them for customers and distributors, so they can and use the predictive models so they can understand where the asset failures could be based on the historical information and some of the behavior that they have seen, and it develops predictive models to analyze that. And that really helps in saving cost, operational cost, and optimizing the processes. Looking at from the supply chain perspective, whereas traditional analytics will help supply chain managers to manage the supply chain. Advanced analytics with the predictions and recommendations help in optimizing their supply chain. So you could generate real-time reports that allows you to manage your inventory. But what about the future needs? What about how can a retailer take care, ensure that they are safe from the what's going to happen in future? Have they looked into what are the predictions and how they can replenish automatically the inventory and per different facility, per product wise, based on the prescriptive models through advanced analytics, and that way they can ensure that they have enough inventory and optimize to their supply chain accordingly to serve the supply demands predicted for the future. So, this is a report from Enterprise Trends in Machine Learning, and which highlights the different areas where advanced artificial intelligence and machine learning projects could have could benefit these different kind of different areas. Customer, and that involves customer experience management, customer engagement, and process automation. They are some of the other two top AI ML use cases. So looking into how this helps in improving customer experience. It helps in generating insights that could help in organizations retain their customers. It also help in acquiring new customers from the artificial intelligence, and from the financial service organizations, generating financial insights and also from detecting fraud. It could prevent the data models, or artificial intelligence can help understand where and understand the fraud, as well as detect fraud so that it could be saved. And in terms of financial planning and managing inventory, supply chain optimization. So these are sort of six different areas where artificial intelligence and machine learning can play a huge role in solving some of the problems. And the pandemic has created a new sense of urgency in getting these organizations getting ready to solve challenges in these different areas. To give you also an example, one of our customers, leased land, they are a one of the largest fleet management company. How they are using advanced analytics for their business growth. They want to understand where their cars could, in terms of predicting if the car is damaged, what portion and could cause more in terms of the fixing, and how they can predict the demand and adjust and optimize their pricing accordingly. How they can predict where their used cars will be sold more, which market is more optimal for used cars, and also to understand, like, predict their customer based on the past behavior, and data models. They can predict the customer response to specific service improvements, and which ads are working better, which keywords are working better. So for all this, you see that to solve these, to really get answers to these questions, they need like multiple different sources. To give you a sense, and this is in general, like a sense, what could be a problem, what could organizations, like huge organizations that are trying to answer some of those kind of questions for their own businesses, facing uh, challenges in terms of, the bigger question is they need trusted data to run, to understand, to get answers to those questions. They need to have access to trusted data. And this is a survey that was conducted by IBM and NASCIO, and it highlights what are some of the bottlenecks or barriers for AI adoption. And based on this data, it shows where organizations stand today. They do not feel comfortable that their data is organized in a manner that they could run these projects. They feel that they have not really assessed their data, what needs and what kind of I mean, uh, what kind of what how much data is usable and how much needs cleansing, and they are uh, not comfortable and answering the question if they have evaluated the risk, and if they're using, would they be able to use, is there a policy so that they would be able to use the data ethically for their needs. So really, the bigger barriers there to understand these, or get like to be prepared for the AI adoption. Some of the barriers are, the organizations are still clinging on to the legacy IT infrastructure, there's a huge paradigm shift that is required in the organization, which is like cultural changes in terms of how data needs to be at the core, and it's not just as a side project, but it needs to be at the core of the business. And to run AI projects, you need specific necessary staff skills, and most important, other one of the factor that I'm going to deep dive in the next the rest of the session is about handling data silos, how they can get that integrated view of the data. And all this, even though all executives understand, but they there's a support system that is required from the executives. So even looking at now in terms of organizations during these times, especially where the pandemic kind of situations where we are today, organizations that have in the past year that have excelled or are able to sustain are the ones who could quickly transform their businesses to accommodate changes in the conditions. And for that, the business need to be agile, and business agility requires technology agility, because if data needs to be at the core, the technology should support that. So, like looking in the middle, the business wants data from all these different sources that are there, and these are hundreds of sources. They are like inventory system, they are log files, or um, reporting tools, or different kind of sources in different kind of formats are available, and they business is asking IT to provide data. They are demanding data from and access to these data from these sources. So, and the IT is responding by hard coding the connection so that they can connect these sources from each other, and among disparate data sources with that, and they're trying to and these connections could be, if they are hard coded, they are unmanageable and they are not scalable. So every time there is a new data source, IT needs to connect or collect the data from those sources and then pass it and make it accessible to business. And in all these processes, business continuity can get affected. One of the organizations have been asking Gartner how they could change what is the new way how they can optimize their IT cost and all. So one of the ways to do cloud adoption, like move to cloud, but that itself is not an easy task. It requires uh, moving all your data without affecting business on a day-to-day basis to cloud. So this, let's see how Gartner suggested in their. This is a slide from one of the Gartner presentations in their conferences, and they suggested the top trends that they are looking into solving data and analytics issues. I mean, solving the issue that we just saw in connecting to different sources, making data available to end users, to data consumers for analytical needs. They introduced this concept called data fabric in 2019, and but recently they elevated it to number three in their conference. And they and really this is they've mentioned that the data fabric is the foundation for accelerating change within a business. So in a couple of years, Gartner has mentioned that if organizations are adopting data fabric, uh, in the couple of years, they will be able to reduce the data delivery time by 30%. So let's look at what is data fabric. This is a definition by Gartner. Data fabric, it's an architectural style. It's not a new technology. It's an architectural style that uses existing technology and automates the design and integration and deployment of data objects, regardless of the deployment platforms and architectural approaches. So when the automation part comes, so this is where AI ML comes in picture. And it mentions in the next paragraph that it utilizes continuous analytics and AI ML over all the metadata assets to get those actionable insights on data management, and make that data available to the end users. This approach will result in faster, informed, and completely automated data access and sharing. So this would really save a lot of time and make data accessible in a much faster way, in a more agile way. And this is what how Forrester defines it, and very similar to what Gartner has defined it. It says dynamically orchestrating disparate data sources intelligently, and where they say intelligently, that's where AI/ML plays a role by predicting, by recommending, and allows you to securely connect to these data sources in a self-service manner, leveraging various data platforms to deliver integrated and trusted data across all different applications. In layman term, if we have to define what is data fabric, it's essentially these 4 points: like integrating data from disparate data sources, securely delivering this integrated view of different data objects, and consuming this integrated data for analytics and operational purposes. The last is the one that says it automates by automating all the entire process using AI and ML. And that's what data fabric is. So if you look at this architecture, if you have to put in a visual sense, this is an architecture defined by or represented by Gartner, which says if you look at the low level, that is all the data sources out there, and then there's data consumers on top, and data fabric sits in between as a middle layer, which provides an augmented data catalog. It gives the data consumers an enriched semantic layer with active metadata, and provides insights for this automation layer, insights and automation layer, and provide and finally providing an integrated view for the data consumers. So data consumers get data from data fabric. They don't have to go to the data sources directly. And that's what data fabric is. It creates a middle layer in between the data sources and data consumers. So why go a logical way? What is a logical data fabric? The logical data fabric is data fabric that utilizes data virtualization as a technology to create that middle layer. And let's look at this diagram and understand the different components. How data virtualization plays a is a core component to uh, to create a logical data fabric layer. And what is data virtualization? So I'm sure most of you are familiar with that, because it's a technology that has been there for a while. And But let's look into it. What are the key components? So logical data layer provides uh, is a logical that provides a high performant real time access to integrated business view across different data sources, no matter what kind of data sources are there. So it creates an abstraction layer. It decouples the business users, data consumers from the data sources. And that way it allows them to, it kind of shields them from the complexity in the underlying data source layer, and provides them the one integrated view. So whether the organization decides to move to cloud, or add new sources, or whatever underlying IT transformation that they're going through, business won't be affected. The business continuity doesn't get affected. That's a huge benefit. And looking at into data, how this data is integrated. This data is integrated using virtualization. The data Basically, data virtualization allows the organization to integrate the data without replicating, without relocating the data out of the physical assets. So replication and moving the data causes a lot of lagging, lot of time, and it doesn't provide an accurate real-time integrated data view. and it uses a lot of resources which could be saved if you just use a virtualized layer instead of and not move the data. It provides Now data virtualization layer provides an easy access to any data in real time at the right time, and it provides a one integrated view to the data consumers. Data catalog is where it's really provides the self-service access to data, and it allows data consumers to easily access, discover their data in a more self-service manner. Data virtualization layer creates a one allows organizations to govern the data in more centralized layer. It provides authorization from one centralized location. And finally, when data is ready, it's available, it's delivered in any format with intelligent query optimization, and it is delivered in any format via semantic layer, and it's tool agnostic. So data consumer, it could be any tool, it could be data tableaus or any other BI tools that could be used to connect and consume the data. So let's look at the logical data fabric layer in a little bit more detail with understanding the unique, like the secret sauce here that makes logical data fabric much more effective and in terms of um, helping organizations conduct more advanced analytics. So this I just mentioned in the slide above that before about query optimization. So query optimization allows it's basically it's as I said, it's a secret sauce that allows organized data virtualization layer to access the data and in a much more agile way. So it for let's say we have a uh, uh, you want to understand what was your understand the consumers, understand the number of from the consumption perspective in the last profitable customers in past 5 years. So query optimization allows the layer to connect to the data sources and compute at the source itself and then get the result back instead of moving the entire data all to compute that and moving the data in the middle layer and then computing it just allows you to compute at the source level and then get the data the results to the logical layer. So that kind of really makes it much more faster and efficient. And then it provides data virtualization provides a semantic layer which allows data users to access the data in any format they need. It could be in SQL, it could be in the form of APIs, or it could be like Denodo's data catalog to discover the data. And all these processes of integrating these different functions of creating views are automated through using AI and ML, and it really helps in like learning the behavior and as it adapts to the how you're creating different kind of views are created and then recommends different views, which is a huge advantage of the logical layer. And then it provides a central place to govern the data, add security, and authorize the right users. So just one place for that allows you to manage the data governance from one central place rather than managing it at individual source levels. So essentially, what uh, this layer, Denodo data virtualization layer, is doing as part of the logical data fabric, it allowing this technology is allowing you to connect to the data sources, combine it, and make it consumable and in a more self-service manner. So now let's look at how our customer has used logical data fabric for big data analytics. Prologis is one of the largest global real estate company. They manage warehouses and distribution centers for large organizations. So they have a lot of moving parts to manage. So they wanted to understand. They were thinking, why should logical data fabric be the backbone of their organization's data architecture? They wanted to their their data landscape was very fragmented, and their business required advanced analytics for quick decision making. They wanted for them speed and agility was very important, and this logical data fabric provided them an agile, more governed approach to business analytics and data science. So let's look at how they what were the goals and how they achieved it. So for them, they wanted to create like a governed data access layer, and they wanted to save time for the data scientists. For them, they whenever there was a new customer, a new client, and then they got new a piece of real estate, they go through detail, in-depth ML, machine learning, and data science processes to understand what would be the right pricing for the contract, or and they look at like historical data to understand the location, type of business for the client, and what they are managing, and come up with the right contract price. Now it's very important for them to do it faster so that they don't lose business, and to understand and to come up with this kind of pricing contract. I mean, the end-to-end consumption of data is required. There are so many moving parts that they need to look at so that they price it optimally. And this is what the data scientists are doing. We're doing, and they want to save their data scientists time and from the just preparing the data. They spend traditionally data scientists used to spend a lot of time in just preparing the data, staging the data for actual analysis. And Prologis wanted to save that time and see how if they could come get the insights much faster. So they created, looking at this architecture, as you see, they have underlying data sources there, different kind of sources, Snowflake, Oracle, just the rig files, Salesforce, Excel files, and then they have like a Tableau sitting on top to consume the data. Now they wanted to, for them, and they wanted to create like a virtual layer in middle. They used Denodo, it's logical data fabric layer to create reusable data assets that could be used by the from the end consumer layer to so ask the right questions and to help provide the insights. So the first layer they created was the base views. They created from base views from the source systems. The second layer was they started creating like building blocks, which was like for in their case, they are real estate companies, so they had buildings, and in buildings they had units, and then these units were leased. They were occupied, so there was an occupancy that they needed to check, and there were financial metrics that they need to look at. So then this layer created those building blocks, and on top of that, they created another layer which help them understand, create one unified view for in terms of occupancy, leasing, and valuations, which were then the data from this views were fed to Tableau to be consumed by Tableau to understand, give them the starter pack for more analysis. Now, these building blocks, which could be reused for different analytic use cases, accelerated the analytics activities by 30%. So now looking into if you in this diagram now you see the orange section. Now that really is the data science piece, which was easily plugged into the logical data fabric layer. And what it essentially did is it used the building blocks that were created for analytic needs and use the same blocks rather than them preparing and going through all the data preparation process. Could just use these building blocks directly. And not only that, data scientists could use these reusable blocks, building blocks, but they could. It helped the analytical tools as well, from the reporting perspective, that whatever uh, predictive model or data insights that data scientists came up with was pushed back to the Denodo, to be pushed back for consumption by other tools as well. So it really helped getting more insights from the reporting perspective or analytical purposes as well. So this is how it was so easier, much easier to connect the data science piece into that architecture. But not only that, it helped data scientists analyze the data in a language they were more comfortable with. It allowed them to create data models on demand, and they were not locked. They didn't have to learn specific tools or gain another skill set, but just use the native language that they were comfortable. And Denodo used this, Prologis used Denodo to leverage the microservices architecture to push the enterprise data into data models, process it, and get the result back. So that, like I mentioned, for consumption from the analytical purposes. So this really helped Prologis get insight, getting insights much faster for quick decision making. It helped them in the pricing and supply chain analytics. And look, from the various different kind of logical data fabric implementations across different customers, we've seen that it has reduced it has helped free a lot of resources so that customers could companies could work on other enterprise projects, could use those resources for the other enterprise project. And it really took less than 50% less time versus any traditional data warehouse approaches. And the result, the data was made accessible for BI and analytical needs in 3 hours versus 3 days. These are some of the uh, our customers who have, to give you a sense of that how logical data fabric was implemented or applied or used by companies across different industries, different regions. So and these so then they use Denodo's data virtualization technology to create the logical data fabric layer. Thank you so much for listening to the session, and I really appreciate the time. Thank you.